Hello, welcome to the Physics Lab. Welcome to the College of North Atlantic Physics Lab. Today's lab we'll be dealing with motion. We're in particular studying when an object is moving at constant velocity and when an object is moved uniformly accelerated. Okay, so this is the apparatus that we'll actually have. We have a cart. Okay, we have two blocks, and we also have a level. Before we even start, we need to make sure that the track is level. Okay, it's level. And the way to do that is to make sure that the bubble is exactly in the middle. Okay, not only in this direction, but also in the direction perpendicular to each other, this way. Okay, so I want to make sure that's actually level. Okay, so I'm just going to do a quick demo on what's happening in the lab. Okay, so basically, Ms. Jacinta is going to do a demo on what to do first, then we'll do the actual lab. Okay, so what she's going to do is just to give it a slight push, like so, and then what we'll do then is we'll, with the motion sensor, it'll actually record the displacement and the time respectively. And then what we'll do is we'll analyze the graph and find the velocity by determining the slope. And the other one is to have this place on one side to basically have the track at an incline, and then Mr. Shida is now going to push it so that what will happen then is it will uniformly accelerate. That's fine. So what's happening there is that because it's at an incline now, Ms. Jacinta actually gave it a slight push, and what happened here is it actually slowed down. It actually decelerated, okay? And then because there's gravity, there's gravity in both directions, and it caused the object to stop momentarily at an instant and then come back down, okay? So in this case here, the cart is actually accelerating. Okay. So we're going to go to page 1. Okay. We're going to go to page 1 and basically have the cart horizontally flat. Okay. So we have here a motion sensor that will actually detect the motion of the cart. So keep in mind that when you're pushing the cart, when Mr. Chin is pushing the cart, make sure that her hand is not in the way, because that will actually block the sensor from recording, tabulating the information. So, one second now, I'm going to turn this on. Okay, just move this side there. Okay, there you go.
Yeah.
Okay. All right. So I'll just move. You can stop there. I'll just give it a little flick there. I'll give it a flick and stop there. Okay, so let's start that. Okay. Flick. Stop there. All right. So this is what we have. Okay, as you can see, it is linear. Now the one we want to analyze, obviously, is here. It's right here. As you can tell, the cart wasn't moving because we didn't do anything. It was at rest. So as soon as I gave it a push, it moved the cart, and then it followed this line, and then of course, it stopped right there. Not stopped, but Mr. Jacinta basically stopped from moving further. So what we want to do is to analyze this side, this part here, this line. We know it's linear, and we know that it's linear, we can find the slope. We can find the slope of this graph. So what we do here is to highlight or block the graph where we want to analyze. Okay, like so. And then we go into this here, the information on the relationship of that line. And we know it's linear, y equals mx plus b. And of course, this one here is, you can just click on that, and right away, it'll give you the slope and the y-intercept. Never mind about the other numbers. What we're concerned with is the 0.418 and the negative 1.13. This just basically tells us the correlation coefficient, how good they are in relation to the points. All right. So from there, we analyze that till we go to page 2. Okay, page 2. Let's do it again. This time, you give it a slightly harder push. Give it a slightly harder push. I'm going to record. Here we go. Now. Okay. As you can tell.
All right, you want to record that again?
Okay. So you can tell the slope from the previous one. See how far that is. So this is actually a little bit more because of the units. It looks like it's the same, but the slope is actually more than the previous one because we gave it a harder push. Okay, so we do this again. Lock it. And then, of course, it's a linear relationship. And then, here we go. Again, the slope is 0.670 and the y-intercept is negative 1.25. If you go back to here, go back to page 1, previous one, the slope is 0.413 and the second one is 0.670. That's actually the velocity of the cart. It's linear, which means that it's actually moving at constant velocity. So by giving it a slightly harder push, increased the slope, and obviously it increased the velocity. Page 3. This time we're going to tilt the track. Tilt the track. And now what we're going to do is give it a push and let it come back on its own. Okay, there? Okay, good. Okay, so record this again. Okay. All right, as you can tell, it's not linear anymore. Okay, it's not linear. So what that means is that this graph is actually quadratic. Okay, it's quadratic. We can easily find the values for the quadratic equation. It's quadratic, and the equation for that is ax squared plus bx plus c. That's the standard equation. And to find the values of a, b, and c. So what we want here is to find the value of a, capital A, because from that we can actually find the acceleration of the cart. So again, we block this. It's good enough there. And then we know it's not linear, it's actually quadratic. We select quadratic, and there you go. So the quadratic tells us that A, coefficient A, is negative 0.234, B is 2.06, and C is negative 3.96. So what we're concerned right now is A, because if we multiply A by 2, it'll actually give you the acceleration of the cart. Let's go on to page 4. This time we'll make it steeper, more steep. Okay, the incline is increased. Okay. All right, I'm going to record again. Okay, I should have stopped that actually. All right, so this is what we want here to analyze. Again, it's the same as before, all right, but the values of A, B, and C are of course different because of a higher incline. Okay, let's take a look again. Let's do this. Let's block a portion to analyze. And there you go, quadratic. Okay, so 0.459. 0.459. Okay, if you go to page 3, it was actually 0.234, and this time now is 0.459. You would expect the acceleration to be to have increased because of the incline has also increased. Just like in the first 2 pages, we gave it a slightly harder push, meant that it actually increased its velocity, its constant velocity. So once all this is done, we go to D2L. We go to D2L. Okay, we go to D2L and answer the questions there. Very self-explanatory. And then from there, you just get the information from the experiment you just did and just transfer the data into D2L, where you're asked to answer all these questions, and then you submit. That's it.